So one thing that always really pissed me off as an organic chemistry student was that the diagrams in the books did not have any explanations as to what was going on. So there is a diagram these books like to draw, and it looks a little something like this. And this is supposed to be clear to you that this is cyclohexane, and it should be really obvious where the axial and equatorial bonds go. And I really appreciate books trying to do this, but I'm going to try to give you my explanation in hopes that if the book does make sense to you, hopefully this will make sense to you. So in a previous video, I talked about where the axial and equatorial bonds come from, and I said that we're going to use we use a Newman projection looking along 4 atoms in the chair projection that are in the same plane with each other. So in the chair conformation, we have 4 atoms, 1, 2, 3, 4, that all sit in the same plane with each other, and then we have one that goes down and one that goes up. So in this type of diagram, it's these 4 atoms here that are sitting in plane with each other. So they're the ones we can draw the Newman projections of. So we'll say the front atoms here are black, and the rear atoms here are blue. What this atom is here is the carbon that goes up. So if we were looking at the projection, this would basically be this atom here. Although we're drawing it right here, it would be this carbon atom, again, with these two and these two being in play with each other. This spot back here is just that CH2 group. And now we can fill in the rest. So how does that help us with drawing the axial and equatorial bonds? Well, this is actually a fairly useful representation if we think about it. Well, if we can understand how to translate this diagram into this. So if this carbon here represents this front black H group, our axial atoms are the ones that point down. In the back, our axial atoms are the ones that point up. Now, they're going to stagger. So axials always go down, up, down, up, down, up. So to draw our axials here, we would put a hydrogen up here and a hydrogen down here. Now, in terms of your equatorial, we know they're equatorial and we know that they are gauche relative to each other, so we don't need to draw that in there. What instead we're going to do is we're just going to draw a line at 90 degrees relative to our axial atoms. So our equatorial here is 90 degrees, 90 degrees, 90 degrees, 90 degrees, 90, and 90. So that's how we're going to identify all the equatorial atoms. The equatorial ones are basically ones that look like they're in plane with the rest of this drawing for the boat conformation. The axials are the ones that go up and down on the diagram. And if you're having trouble seeing that, this is how you backtrack into the Newman projection. Now, the limitation with this Newman projection is that it's not showing you how these CH2 groups, how their hydrogens are aligned. So this is going to be a lot better for seeing all the axial and equatorials, but again, this is how you translate between the two diagrams.